very last video of chapter 4 is rational inequalities. So an example of a rational inequality is anything that has an x in a denominator with an inequality sign. We are going to solve this in a very similar way to polynomial inequalities. So the only difference is that when I break my x-axis into what we call the critical values are going to be your x-intercepts and your vertical asymptotes. Okay, so these are going to be the two pieces of information that are super important for these graphs. So what I've done first is I want you to be able to look at this graph of this inequality and see if you could solve it. So if I asked you, where is this graph greater than 0? You'd be looking for all the green parts that are greater than 0. So it's this part here, and then it would be this whole section over here. So these are all the parts where the value of your function is greater than 0. So how do I describe these? Well, maybe you could look at the graph and be like, hey, it's greater than 0 everywhere from -2 to this y or this x-intercept at 1.5 or 3/2. And then you could say it's also from 2 up until infinity. Now, if you couldn't see that on the graph, how do we find these values? Well, these values are our vertical asymptotes and our x-intercepts. So just to remind you how to solve for these, to find an x-intercept, make your equation equal to 0, right? Just like solving a polynomial inequality. Make it equal to our zeros. Then I'm going to multiply that by the lowest common denominator, x squared minus 4. I'm left with 2x minus 3 equals 0, which would give you 2x equals 3, and x is equal to 3/2. So that's that x-intercept. So if I was looking at this from a critical value point of view, I have an x-intercept at 3/2. Then vertical asymptotes you find by letting your denominator equal to 0. So x squared minus 4 equals 0. You can solve this using the square root method, or you could solve it by factoring. So we usually factor things. So we'll go x minus 2x plus 2. So we know we have vertical asymptotes at -2 and 2. So I would put a vertical asymptote at -2, and I'd put a vertical asymptote at 2. But I would circle them so that I don't forget that these points don't actually exist in case they're asking me where is the graph equal to 0, right? You can't equal an asymptote. And then I would test points. I would test -3, I would test 0, I would test, 1.8, and I would test 3. And it would come out below the x-axis, above the x-axis, squeak in a below, and then above again. And again, 90% of your graphs, hopefully you noticed from 4.5 that most of the graphs alternate above, below, above, below. There's a few that are above, above, or below, below, but it doesn't happen very often. Okay, so when we look at this, we can now see that it's the interval between -2 and 3/2 that's above the x-axis, so the y values are greater than 0, the y values are positive, and again from 2 to infinity. Okay, so I want you to pause the video and try this one. So again, just from the graph, and then see if you can reinforce it. So can you look at this equation and say, oh yeah, that's because my horizontal or my x-intercepts are this and my vertical asymptotes are this. Okay, so from a graph point of view, where is it less than or equal to 0? It's less than or equal to 0 in this little section down here. So this is approaching my vertical asymptotes. I kind of have to find them to solve this. So my x-intercept I find by letting y equal to 0. So I would do 1 over x plus 4 is equal to 0. Multiply by the lowest common denominator, I'm left with 1 equal to 0, and there are no x-intercepts. Then to find my vertical asymptotes, I let my denominator equal to 0. So I can see that the vertical asymptote at -4, right? It's that vertical line here. So if I was to break this axis up into its critical values, I have a vertical asymptote at -4. And then if I test intervals, I find my graph is below and above. So then I would answer everything to the left of -4 is true. So the solution is -infinity up to -4, and it's never equal to 0. Because the only part that has like a critical value on the x-axis is an asymptote. All right, now let's move on to not having a graph. So if you're solving rational inequalities, number 1, find an equivalent inequality with 0 on one side. Super important, just so you can tell if you're looking above or below. And then you're going to find your critical values. So I want you to find your x-intercepts. I want you to find your vertical asymptotes. Then you're going to break up your x-axis into these critical values. Then you're going to test between those intervals, so between the critical values, to determine if you're above or below. And then you're going to solve your inequality. Sounds easy, right? So here we go. First step is to find your zeros, right? It's already an inequality set to 0. So to find your zeros, you're going to make it equal to 0. So we've got x minus 5 over x squared minus 9 is equal to 0. Multiply by the lowest common denominator, you're left with x minus 5 equals 0, and we have a 0 at x equals 5. Then we want to look at our vertical asymptotes. It's whatever would make your denominator equal to 0. So that's going to be plus or minus 3. Right? So whether you did it using a difference of squares or whether you solved it using the square root method, those are my two vertical asymptotes. So now I'm going to take my x-axis and I'm going to put those on. So I have an asymptote at -3, circle it, you cannot be equal to it. You've got a vertical asymptote at 3, again circle it, you cannot be equal to it. And then you have an x-intercept at 5, you can be equal to it. Now we have to figure out above or below. So we're going to test values. We're going to test -4. We're going to test something like 0. We're going to test 4. And we're going to test 6. So how do we choose these values, right? Anything to the left of -3, like -4. Anything between -3 and 3, like 0. Anything between 3 and 5, so 4. And anything greater than 5, so 6. And we're going to plug these into the equation. So I get -4 minus 5 over -4 squared minus 9. Now again, I'm not actually looking for the value. I don't have to use my calculator. What I care about is it positive or is it negative? So this would be -9, which is negative, over 16 minus 9, which is positive. So to the left of -3, my graph is negative, because a negative divided by a positive is a negative. If I try 0, I get 0 minus 5 over 0 squared minus 9, leaves me with a negative divided by a negative, which is a positive. Ooh, my graph is flopping. That feels good. Pretty sure it's going to go negative positive, but let's check. So for this one, if I plug in 4, I've got 4 minus 5 is negative, and I've got 16 minus 9 is positive. Look at that. It's negative. And if I plug in 6, I've got 6 minus 5 is positive, over 36 minus 9 is positive. I'm left with positive. Sweet. So now I'm going to solve the inequality. Where is my graph less than or equal to 0? So that's going to be anywhere that the y values are negative. Now, it says equal to, but I can't be equal to an asymptote. So it's going to be round bracket to the left. It's going to be round bracket to the right, but ending at a beautiful square bracket, because you can be equal to 5. So my final solution for this would be -infinity up to -3, or 3 up to 5 inclusive. All right. Okay, so this last example is like the ultimate example. So this is one where you have a rational function, but it's not set to 0. So the first thing we're going to do is set it to 0. So to do that, I'm just going to take one term and subtract it from one side. So I always take things to the left because I like it that way. So I'm going to subtract x plus 2 over x minus 5. And it's going to be greater than or equal to 0. So that tells me that I'm going to be finding where the value of my function at x is greater than or equal to 0. Now I need to find my critical values. So my critical values are my zeros and my vertical asymptotes. To find your 0, you're going to take your equation and you're going to set it equal to 0. So x minus 3 over x plus 4 minus x plus 2 over x minus 5 equals 0. Now to solve this, you have two options. You could create a common denominator of x plus 4 times x plus 5, and if you do that, it will actually help you with your interval thing. So if you want to do that, you could do one giant denominator, right? And then you get a new function, and then you can set it equal to 0 and solve for the zeros. Or you could use that lowest common denominator, which isn't going to change, of x plus 4 times x minus 5, and you could destroy the denominators. Regardless, everybody, even if you create a common denominator or you destroy with a denominator, we're all going to have the same next step. So I'm going to pause the video, and then when you've created that lowest common denominator or destroyed with the denominator, see if you have the same as me. Okay, so you should end up with x minus 3 times x minus 5 minus x plus 2 times x plus 4 equal to 0. Now we have to solve the resulting equation. So I'm going to distribute through. So I end up with x squared minus 5x minus 3x plus 15. And then I'm going to leave this minus sign here with another bracket. So I'm going to distribute these two brackets before I deal with the negative. So then I get x squared plus 4x plus 2x plus 8 equals 0. Then I'm going to distribute the minus sign through and collect like terms at the same time. So I end up with x squared minus 8x plus 15 minus x squared. Now this is 6x, so I'm going to subtract 6x minus 8. Okay, now I'm going to collect like terms. I've got negative 8x minus 6x is minus 14x. And then 15 minus 8 is 7. Then I'm going to solve for x. I get negative 14x equals negative 7. And I'm going to divide by negative 14. Sometimes I show this one because people always try to divide the other way. And you should get x equals a half. So now I know one of my critical values is that my x-intercept is a half. Now I have to find my other critical value. So my other critical value is my vertical asymptotes. We'll just do them down here. So the vertical asymptote, I'm going to set the denominators equal to 0. So I could create a common denominator and see them together, but really it's just the fact that x plus 4 can't equal 0 and x plus minus 5 can't equal 0, right? So those are going to be the equations of my asymptotes. So x equals negative 4 and x equals 5. Now I'm going to break my axis up into those critical values. I've got negative 4, I've got 1/2, and I've got 5. I cannot equal negative 4, and I cannot equal 5. Okay, so let's test. I'm going to test something like negative 5 in this interval. I'm going to test something like 0 in this interval. I'm going to test something like 1, and then something like 6. Now in reality, I test 0. I pretty much trust that these are all going to swap. You guys can let me know if you find one that doesn't. But what are you plugging it into? Well, f of x is equal to, let's back up here, x minus 3 over x plus 4. So x minus 3 over x plus 4 minus x plus 2 over x minus 5. X plus 2 over x minus 5. So this is what I'm plugging the values into. So I'm going to plug in 0. Let's find f at 0. I get 0 minus 3 over 0 plus 4 minus 0 plus 2 over 0 minus 5. Now if you had created a common denominator, you could be using that now. You would have negative 14x plus 7 over x plus 4x minus 5, and then you could do that whole sign thing. But because we don't have a common denominator here, we have to actually use our calculator. So 0 minus 3 is negative 3, divided by 0 plus 4 is 4, minus 0 plus 2 is 2, divided by 0 minus 5 is negative 5. I get negative 0.35. which all I really care about is that it's negative. So in this section here, I'm negative. So I'm betting that it's going to go positive, negative, positive, negative. Let's check some. So let's check something like f at 1. If I plug in 1, I get 1 minus 3 over 1 plus 4 minus 1 plus 2 over 1 minus 5. If I plug that in, I'm going to plug in negative 2 divided by 5, right? I'm doing the addition in my head. Minus 1 plus 2 is 3, divided by 1 minus 5 is negative 4. That gives me positive 0.35. So I checked 1, and look at that, it was positive. Whew. If I check 6, and if I try to check negative 5, it's going to come out positive and negative respectively, or negative, positive respectively, whatever. Okay, now all we have to do is solve my inequality. So the inequality wants to know where is the value of your function greater than or equal to 0. So that is going to be here, greater than or equal to 0, but I can't be equal to an asymptote. And then in here, so I can be equal to an x-intercept, and I cannot be equal to an asymptote. So my final answer would be negative infinity to negative 4 round bracket, or 1/2 to 5 square bracket to round bracket. All right. That is 4.6. Good luck on your chapter 4 test, and don't forget that this chapter does have a journal.